Okay, next unit is going to be about, or next section is going to be about composite and combinations of functions. So we're going to talk about finding domains again, and then the algebra of functions, meaning addition, subtraction, multiplication, division of two functions. So first, as a reminder, when we're talking about exclusion from domains, remember we cannot divide by 0, and the other thing we cannot do is take square roots of a negative number, and really that even really means even index. So no square root of negative, no division by 0. That's going to be a big part for this section. Okay, so looking at a couple examples, here we don't have any division in this first one, no square roots, so the domain would be all reals. Okay, in this second one here, h of x, remember we can't take square root of a negative, so we need to make sure that this remains positive, greater than or equal to 0. Solving that, we'll have 3x is greater than or equal to negative 12, and so x will be greater than or equal to negative 4. So you can either say that your domain has to be greater than or equal to negative 4, or you could say that x cannot be less than negative 4. So either one of those would work. Okay, the last one then, we cannot divide by 0, so if I set this denominator equal to 0 and factor, I get x minus 3 and x plus 1. Which tells me x would be 3 or negative 1. So really we can say all reals except for x cannot be 3 and x cannot be negative 1. Okay, that's a reminder on how we did some domain stuff. Our algebra of functions then, what we have here is some difference product quotient, so it just means that we're going to add f of x and g of x, and we are going to then remember to combine like terms. That's the big one here. For the difference of functions, f of x minus g of x, again, we're going to combine like terms, but before you do that, you need to remember to distribute that negative sign. Okay, next one, product then, just means we're going to multiply the two things. This could involve foiling, it could involve a binomial times a trinomial. You just need to remember to distribute appropriately. So again, we're going to distribute every term from f of x into g of x. And then finally the last one, a quotient or division, is f of x over g of x. And here we also need to add that that g of x cannot equal 0. Okay, our denominator can't be 0 because, like we just said, that violates our domain issues. So an example of each of these then, what we're going to do is just add the two together on the first one, plus 3x minus 4 plus a negative 2x, and that should be plus 5. Hey, combining like terms, I get x squared plus x plus 1, and that would be it for the addition. On the second one, this is where we need to be careful. So I'm going to subtract, and then I'm going to put in parentheses that negative 2x plus 5. So remember, I need to distribute the negative. So x squared, 3x minus a negative 2x is going to give me plus 5, and negative 4 minus plus 5x. And negative 4 minus 5 is going to give me a minus 9. Okay, that would be our subtraction. If we do multiplication, we're going to have x squared plus 3x minus 4 times a negative 2x plus 5. So this one we're going to have a little bit more work. We're going to need to distribute, remember, each piece of f of x onto the next one, onto the g of x. So we're going to have a negative 2x cubed. Let's start that over. Okay, negative 2x cubed plus 5x squared. So that would be the x squared, done with that one. Plus, we're going to have a negative 6x squared plus 15x. And then distributing the negative 4, finally, we're going to have plus 8x minus 20. And if I combine like terms, I get negative 2x cubed plus a negative x squared, or you can just say minus x squared, plus 23x minus 20. Okay, and then that would be the end of our product of those two. And then finally the last one, f over g. So I'm going to say x squared plus 3x minus 4 all over negative 2x plus 5. Okay, and on this one again, when negative 2x plus 5 can't be 0, we are going to actually use that now. So this would be it. Okay, you're also going to want to add to this, actually, we need to factor, if we can, and simplify. Okay, there's numerator factors, but it won't simplify, so we're going to leave it as it is for right now. It would factor to x minus 4, plus 4, and x minus 1. Okay, that would be the numerator, which won't cancel out with anything. Now, moving on from that to talk about domain. So we said that the first one was x squared plus x plus 1, and then when we subtracted x squared plus 5x minus 9, x squared plus 5x minus 9, multiplication, whoops, wrong way, whoops, there we go. Multiplication gave us a big long thing, negative 2x cubed minus x squared, negative 2x cubed minus x squared, plus 23x minus 20. And then finally on the last one, remember after we factored was x plus 4, x minus 1, all over negative 2x plus 5. Okay, when we talk about the domain, most of these are going to be fairly easy and simple. Right? This is just a polynomial, no division, no square roots, so our domain is all reals. Same thing for this one, and actually same thing for part C. The only one where we have a domain issue is in that third one, so I'm just going to take my denominator and set it equal to 0. Subtracting 5 and dividing by negative 2, I get that 2.5, which means our domain is all reals except 2.5, because we can't have 0 in the denominator. Alright, so that is it for this lesson. That is how we do the algebra functions. You're just combining like terms, really. Remember to factor when you do quotients. Okay, so add that back into your notes if you haven't done it yet. Factor when you do quotients and try to simplify, meaning cancel things out. And other than that, we will see you next session.